Hi, welcome to this video. We will cover the concept of a moment in this video and learn what exactly it is. Let's quickly look at the concept of force first. What is a force? A force is a quality that changes the motion or inertia of an object. For example, to pull up a weight using a rope and a pulley, one needs to apply force to the other side of the rope as you see in the image. Moment is also a quality. Moment, however, is a quality that changes the angular motion of an object. For example, to make a Ferris wheel rotate, you must apply a moment at the center of the wheel. One important note is that forces are fundamental natural phenomena that exist around us and are governed by basic physical principles. In the pulley example that we have, the electromagnetic repellent forces between atoms in the hand and the rope are the actual source of the force. Moments, on the other hand, are a byproduct or side effect of forces. We need to have a force present to create a moment. So without a force, there will not be a moment. Imagine, we have an object hinged to the wall at point O. And we are applying a force F to this object. We can intuitively imagine that this object would want to rotate around the hinge due to the force. So we can define the moment of the force F about the point O quantifies the tendency of the force to rotate the object around the hinge. The magnitude of the moment is proportional to the distance that the force has from point O. In this case, the distance is the radius of the dashed circle shown as r. So we can write moment, shown here with letter m, is equal to radius times force. In general, the moment of the force F around the point O is a vector that results from the cross product of the position vector r and the force vector F. So, let's look at this more closely. We define a coordinate system with the origin of O and define the position vector and the force vector. We define these two vectors mathematically. The radius vector is equal to r multiplied by I because it is solely in the x direction. And the force vector is equal to F multiplied by j because it is solely in the y direction. Afterward, we can perform the cross product operation, and we get the moment vector around point O is equal to r times F times k. This means that the magnitude of the moment is r times F as we saw previously, and the moment vector is in the z direction, which is outward from the screen of the device you are using to watch this video. We can also show this moment using a curved arrow in our image. A counterclockwise direction means a positive z direction in our example. Now, let's look at the moment calculation in a more general sense. Assume that we have a force in space, and we want to calculate its moment about a random point O. First, we define a general coordinate system. And we determine the position vector of force F with respect to point O. We use this coordinate system to define the force and position vectors mathematically. We define the force vector with three components, one in the x direction, one in the y direction, and lastly one in the z direction. We use the variable f with a subscript to show the magnitude of the force in each direction of the coordinate system. Similarly, we define the position vector with three components with variable r as the magnitude component. As we saw, the moment of F around point O can be calculated using the cross product of r and F. Let's use this convention to show the moment of F around point O. Now, let's go through the cross-product calculations process. From our algebra classes, we know that we can calculate the cross product of two vectors by computing the determinant of the 3x3 matrix that is formed using the unit vector of the coordinate system, the position vector, and the force vector. The first row of this matrix is the unit vectors of the coordinate system that we are using. The second row is the components of the position matrix in the x, y, and z directions. The third row of the vector is the components of the force vector we have in the x, y, and z directions. the resultant moment vector will generally have three components, one in the x direction, one in the y direction, and lastly one in the z direction. We should the magnitude of the moment with the letter m and a subscript corresponding to each direction. Using algebra and calculating the determinant of the matrix, we get the value for each of the components of the moment vector. We can also write the answer as the whole vector, and as you can see, it is gonna be very long. Now, let's look at an example to understand everything better. Imagine we are going to fasten a bolt using a wrench. We apply a force at the end of the handle of the wrench. We want to calculate the total moment that this force is causing on the bolt. We define point O on the bolt's body. We assume the length of each section of the wrench is A and B respectively, and these two sections are normal to each other. We define a coordinate system at point O with two of its axes along the arms of the wrench. This coordinate will make our life easier for calculations. You may choose the coordinate system anywhere else. Let's draw the point O in our coordinate system again and draw the position vector for the force vector that we have. Based on this drawing and assuming a magnitude of F for the force vector, we define the force and position vector mathematically. After performing the cross product, the moment vector can be calculated. Thanks for watching this video. Hit the like button and subscribe if you liked it. Please also leave a comment and share your opinion.